Well, hello there, chemistry students. We're going to try to go through some tips on how to learn anions, the negative ions. And in all honesty, it's quite a bit tougher than the cations. So, first of all, there are a group that we can get right off the periodic table. So, I'll start out with the halogens. Halogens have 7 valence electrons. They want one more. So fluorine, chlorine, bromine, iodine all gain 1 electron. They form -1 ions, and with these, they change their name. They all change their name to end in the letters I, D, E. So fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, iodine becomes iodide. Now, if you look at the next column, they have 6 valence electrons. Well, they want to gain 2 electrons, and when they do that, they become -2 anions, or 2 negative anions. Oxygen becomes oxide, sulfur becomes sulfide, selenium becomes selenide. If we keep going, this column, they want to gain 3 electrons. Nitrogen becomes nitride, phosphorus becomes phosphide. Arsenic, I don't think, was on our list to learn, but it would become arsenide. If you talked about a -4 form of carbon, it would be called carbide. These are, let's see, 8, 9. These are 9 of the ions that you have to study. And then one more. Turns out hydrogen very often forms a positive ion, but sometimes if it's bonded with other substances, hydrogen becomes a negative ion. So what do we have? We'd have hydride. Over on this side, we've got iodide, bromide, chloride, and fluoride, oxide, sulfide, selenide, nitride, phosphide. Okay, so that gives us 10 ions that we can get pretty easy from the periodic table. Okay, the halogens all want to form -1 ions. The oxygen family wants to form -2 ions. The nitrogen family wants to form -3. And hydrogen only has 1 electron, so if it gains an electron, it would become hydride. If it loses an electron, then it's the hydrogen ion. All right, now how do we do some of the rest of these? These are much tougher. I'm going to break them up into a couple of groups. This is kind of how I'd suggest you do it, is you take this original 10, make sure you know them. Then let's add in something. So what are we going to add in? Here are 3 ions that all end in IDE. So their names are similar to the ones that we already had on our list. But these are not monatomic ions. These are polyatomic ions. And so hydroxide is just a OH group, cyanide is a CN group, and peroxide is 2 oxygen atoms attached to each other with a 2- charge, which effectively means there's only 1- on each. There's really no way to get around this other than a bit of memorization. So I'll throw these out there that they are IDE endings, and so after you learn those first 10 with the IDE endings, maybe add in these 3. Okay? Then let's pick up a couple of groups. I'd suggest that you try to work these in pairs. We got sulfite and sulfate. We've got nitrite and nitrate. We've got phosphite and phosphate. And if you look at them and you try to put that together and see what's the pattern, I wish I could tell you it was just based on the number of oxygen. It's not quite like that. It's on the fewest or the most number of oxygen. So you're going to have to learn that sulfite and sulfate are the SO3 and SO4. They both have a 2- for the charge. The one with the fewer oxygen gets the ITE ending, and the one with the greater number of oxygen gets the ATE. So if you can remember that there's SO3 and SO4, the SO3 goes with ITE, sulfite. The 4 oxygen goes with sulfate. When you get to the nitrogen and oxygen ion, there's an NO2 and an NO3. Both of them have a single minus. The fewer number of oxygen becomes nitrite. The greater number of oxygen becomes nitrate. Phosphite, phosphate. Both of them are 3-. One's a PO3, one's a PO4. The fewer goes with the ITE ending, phosphite. The greater goes with the ATE ending, phosphate. Kind of work them in. Start out with your other ions that you've already got, and then say, all right, I'm going to work sulfite and sulfate. I'm going to add that in with my mix, and then I'm going to add in nitrate and nitrate, and I'm going to add in phosphite and phosphate. All right, I'm going to show you a series of ions. We got ClO minus, we got ClO2 minus, ClO3 minus, and ClO4 minus. Well, now what are we going to do? We got 4 different ions of chlorine and oxygen. They all have the same charge, minus. But remember I said the fewest goes with ITE and the greater goes with ATE. So we're going to split them 2 and 2. These two are both going to end in ITE. These are both going to end in ATE. But we can't have 2 chlorites. See, the other part of the name comes from this other element, chlorite. So they both are going to end in ITE. How to tell them apart is going to be a prefix. So the one with the fewest oxygen is going to get the prefix hypo in front of it, hypochlorite. So then this next one is just regular chlorite. Now we've got 2 that are going to have the ATE ending. So ClO3 is just going to be chlorate. And ClO4, this has the most oxygen. It's going to get a prefix in front, perchlorate. I sincerely wish that we could take that pattern and just relate it to number of oxygen and use it for all of ours. Doesn't work that way, unfortunately. But it is a pattern. And when you look at your ion list, while the chlorite and hypochlorite, chlorate, perchlorate, these are the only ones that are on your quiz list. There are other ions shown on your sheet where we could just replace chlorine with another halogen like bromine. And we could have hypobromite, bromite, bromate, perbromate. We could replace it with fluorine, and we could have hypofluorite, fluorite, fluorate, perfluorate. We could do iodine, hypoiodite, iodite, iodate, periodate. So while I don't have all those ions on your quiz list, they would be easy enough to learn, to add in, once you learn this pattern. Remember, this one was called sulfite? Well, sometimes there's a hydrogen that attaches to this. So it would be an H plus that attaches. And so if this was sulfate, this is going to be called hydrogen sulfate. But hydrogen sulfate also has just kind of a, an extra name. It's called bisulfate, which is a lot shorter and easier to say than hydrogen sulfate. So once you know your sulfate and sulfite, you can add in hydrogen sulfate. Couple more. Here's an ion called carbonate. Well, if you put a hydrogen with it, it's hydrogen carbonate or bicarbonate. At home in your kitchen cupboards, I bet you have somewhere a box or container of baking soda. Baking soda is a compound of sodium bicarbonate. So you have sodium and Na plus and bicarbonate HCO3 minus, and they add up to 0. Here's two more that you probably want to learn together. Chromate. This one's got kind of like two chromates are stuck together. One of the oxygen is missing in between. And it's called dichromate. Both of them have a -2 charge. So, again, you're just going to have to try to work on learning what they are. Memorization. Last two. Well, we've got manganese with some oxygen. So whenever you got the oxygen, you're guessing that you got a ATE or ITE ending. 4 oxygens, quite a few. So it turns out we got manganate, but it's named kind of like the halogen ones where we've got the per in front, permanganate. Just study it. And the last one's a weird one. It's actually coming from organic chemistry, where we have, carbons bonded together in a chain and hydrogens and oxygens all attached within that. C2H3O2. This is the acetate ion. And that's another one that you have at home somewhere in your kitchen or maybe the laundry room, because vinegar is a solution of acetic acid, which is just, if you combine this with a hydrogen ion, HC2H3O2, you'd have acetic acid. So the anions, as I said, are definitely harder to learn. It's going to take some practice, but these were some tips on how you might want to group them together to help you out.